Hi, my name is Annie, and I'm excited to share this project with you. White matter composes about half the brain and forms pathways that are essential for communication between regions. Myelination is a key neurodevelopmental process in which a fatty sheath, known as myelin, envelops the neuronal axons that form white matter tracts, acting as insulation and allowing for efficient conduction through these pathways. If myelination does not proceed properly, detrimental cognitive and mental health impacts can result from the failure of tracts to send signals effectively. My focus is on a very specific and interesting white matter tract, the vertical occipital fasciculus. The history of this tract is especially fascinating, as it was discovered in 1881 by the famous neuroanatomist Carl Wernicke, and appears in this image from 1909. It then disappeared from the literature for over 100 years because his more influential mentor did not believe that a vertical tract, running from top to bottom rather than front to back in the brain, could exist. It was recently rediscovered and is of great interest, as it is the primary tract connecting the two main visual processing pathways: the dorsal stream, which processes spatial information, and the ventral stream, which processes object information, including faces. I'm involved in a study of a rare genetic disorder called Williams syndrome, in which the concepts of dorsal and ventral stream are particularly important. Williams syndrome is caused by the hemideletion of about 25 genes on chromosome 7 and is characterized by impaired visuospatial construction abilities and increased social drive. fMRI studies in individuals with Williams syndrome show increased engagement of the ventral stream in response to faces, decreased engagement of the dorsal stream during visuospatial processing, and alterations in communication between these two regions. In this unique study, I get the chance to observe how specific genes impact myelination of an important pathway connecting these two processing regions. I investigated a longitudinal cohort of individuals with Williams syndrome and typically developing controls. We used a cutting-edge MRI method to quantitatively assess myelin. I then extracted average myelin from the vertical occipital fasciculus using these regions of interest and analyzed developmental trajectories. These analyses produced some interesting differences between individuals with Williams syndrome and typically developing individuals, as shown by these graphs. The graphs have age on the x-axis and myelin on the y-axis, and show individuals with Williams syndrome in red and typically developing in blue. Interestingly, individuals with Williams syndrome had higher average myelin in the right vertical occipital fasciculus, which aligns with previous findings that face processing is right hemisphere dominant. Future work on this major neurodevelopmental event will examine how structural differences in myelin of the vertical occipital fasciculus may relate to behavioral and cognitive profiles, specifically spatial and social stimuli processing. Thank you for listening.